Imagine standing on the runway and watching an aircraft so terrifying that it doesn't just look like a fighter jet, it looks like a giant eagle ready to strike. A machine with eyes that seem alive, a razor-sharp golden beak, and a design built to intimidate every enemy before it even takes off. What if I told you that this futuristic aircraft could combine stealth, artificial intelligence, hypersonic technology, and unmatched air superiority into one breathtaking machine? Is this the future of American air power, or the beginning of a completely new generation of combat aircraft? Stay with me until the end, because what you're about to see will completely change the way you think about military aviation. The aircraft before you is known as Eagle 1. While this is a concept aircraft inspired by America's symbol of strength and freedom, every detail of its design is based on technologies that are either already being developed or expected to shape the future of military aviation. From the very first glance, Eagle 1 doesn't resemble an ordinary fighter jet. Its aggressive front profile is inspired by the bald eagle, America's national bird. The golden beak isn't simply an artistic feature, it represents precision, dominance, and power. The sharp glowing eyes create an intimidating appearance that would have an enormous psychological impact during military demonstrations and operations. Military aircraft have always been designed with one primary goal: surviving the battlefield while completing the mission. Eagle 1 takes that philosophy even further by combining stealth engineering with a biological design language inspired by nature's most powerful predator. Every surface appears smooth and carefully sculpted. The feather-like patterns across the nose aren't real feathers. Instead, they represent specially engineered radar-absorbing composite materials designed to scatter incoming radar waves. Unlike traditional flat stealth aircraft, Eagle 1's organic curves could potentially reduce radar reflections from multiple angles while maintaining exceptional aerodynamic performance. As sunlight reflects across the aircraft's metallic body, the white, black, and gold color combination immediately captures attention. White symbolizes vision and clarity. Black represents stealth and mystery. Gold symbolizes excellence and strength. Together they create an aircraft that looks more like a living predator than a machine. The cockpit canopy is seamlessly blended into the upper fuselage, minimizing radar reflections while providing the pilot with exceptional visibility. Future fighter aircraft may even eliminate traditional cockpit frames entirely, using advanced transparent displays projected directly onto the canopy itself. Inside Eagle 1, technology would replace nearly every traditional instrument found inside current fighter aircraft. Instead of dozens of buttons and switches, the cockpit would feature massive panoramic touch displays integrated with artificial intelligence. Every sensor, radar system, communication channel, targeting system, and engine status would be displayed through adaptive digital interfaces. The pilot would no longer spend precious seconds searching for information. Instead, artificial intelligence would prioritize threats automatically. Enemy aircraft approaching from behind? Instant warning. Incoming missile? Automatic defensive suggestions. Fuel optimization? Handled by AI. Electronic warfare? Managed in real time. The aircraft itself would become a highly intelligent combat partner rather than just another machine. Helmet-mounted displays would project enemy locations directly onto the pilot's visor, allowing targets to be tracked simply by looking toward them. Eye movement alone could select targets. Voice commands could activate combat modes. Artificial intelligence would constantly calculate millions of battlefield possibilities every second, offering the safest and most effective solution before the pilot even finishes making a decision. But intelligence alone doesn't win wars. Speed changes everything. Eagle 1 is imagined with twin next-generation adaptive cycle engines capable of automatically changing airflow depending on mission requirements. During stealth operations, fuel efficiency would be prioritized. During combat, maximum thrust would instantly become available. These adaptive engines could provide significantly greater efficiency than today's fighter engines while producing tremendous power whenever needed. Imagine standing behind Eagle 1 as both engines ignite. The runway begins vibrating. Heat waves distort the air. Within seconds, the aircraft accelerates like a missile. The afterburners illuminate the runway with bright orange flames. Then, almost effortlessly, Eagle 1 disappears into the sky. Its climb rate would be astonishing. Its acceleration breathtaking. Its sound unforgettable. Future propulsion technologies may even include variable exhaust systems capable of reducing infrared signatures, making the aircraft much harder for heat-seeking missiles to detect. Stealth is no longer just about radar. Modern warfare requires invisibility across multiple spectrums. Radar, infrared, electronic emissions, acoustic detection. Every one of these must be minimized. That's where Eagle One truly stands apart. Instead of carrying missiles beneath its wings, all weapons would be stored inside internal weapon bays. The smooth outer body remains clean and aerodynamic. Doors open only seconds before launch. Missiles fire. Doors close immediately afterward. Enemy radar has almost no opportunity to identify the aircraft. Electronic warfare systems would surround the aircraft with invisible layers of protection. Powerful onboard computers could detect enemy radar frequencies long before the aircraft itself is discovered. Rather than simply avoiding threats, Eagle One could confuse them. False targets. Radar deception. Signal jamming. Digital warfare. In future conflicts, destroying enemy sensors may become more important than destroying enemy aircraft. Information wins battles. Whoever sees first, usually shoots first. That philosophy defines modern air combat. For decades, fighter aircraft relied heavily on powerful radars mounted inside the nose. Eagle One expands this concept dramatically. Its entire body could become a network of distributed sensors. Tiny infrared cameras embedded throughout the aircraft continuously scan every direction. Advanced electronic sensors detect radio transmissions from hundreds of kilometers away. Optical tracking systems identify moving aircraft without emitting any detectable signals. Every sensor feeds information into one central artificial intelligence system. Instead of presenting dozens of disconnected screens, Eagle One creates one complete battlefield picture. The pilot sees everything. Friendly aircraft. Enemy aircraft. Ground threats. Missile launches. Weather changes. Satellite information. Drone positions. Everything appears as one unified tactical environment. Future combat pilots may never need to search for information again. The aircraft itself becomes their eyes. And perhaps even their instincts. What truly separates next-generation fighters from previous generations isn't just speed or stealth. It's teamwork. Eagle One isn't imagined as fighting alone. Instead, it could command an entire fleet of autonomous combat drones. These unmanned wingmen would fly alongside the main aircraft, extending its sensors, carrying additional weapons, and even protecting the pilot from danger. One drone scouts ahead. Another jams enemy radar. Another launches precision weapons. Another intercepts incoming missiles. The pilot commands the entire formation as though leading an airborne squadron. Artificial intelligence coordinates every movement within milliseconds. No radio delay. No confusion. Perfect synchronization. Instead of risking multiple human pilots, only one pilot remains inside Eagle One while intelligent unmanned aircraft handle the most dangerous missions. This approach represents one of the biggest transformations in military aviation history. Future wars may no longer be fought aircraft against aircraft. They may become intelligent networks fighting intelligent networks. And Eagle One is imagined as the commander of that network. As Eagle One continues climbing higher into the atmosphere, the battlefield below becomes nothing more than a digital map displayed across the pilot's panoramic cockpit screen. Every movement, every radar signal, every aircraft in the sky is instantly analyzed by artificial intelligence. Instead of reacting to danger, Eagle One is designed to predict it before it happens. Imagine an enemy radar station hundreds of miles away attempting to detect the aircraft. Instead of receiving a clear radar return, the enemy operators begin seeing confusing signals. Multiple false aircraft suddenly appear across their screens. One seems to be flying north. Another appears at a completely different altitude. Yet Eagle One remains invisible, silently approaching its objective. This level of electronic warfare could completely transform future air combat. Modern military strategists often say that the aircraft which controls information controls the battle itself. Eagle One embraces that philosophy completely. The aircraft is imagined with an advanced sensor fusion system that continuously combines information from satellites, airborne early warning aircraft, reconnaissance drones, naval vessels, and ground forces into one real-time tactical picture. Instead of operating alone, Eagle One becomes part of an enormous digital battlefield. Every friendly unit shares information instantly. Every detected threat becomes visible across the entire network. Every missile launch is tracked within seconds. This creates something military experts call battlefield dominance. But technology alone cannot guarantee survival. Speed remains one of the greatest advantages any aircraft can possess. Future propulsion systems could allow Eagle One to cruise at extremely high speeds while consuming far less fuel than today's fighter aircraft. Adaptive engines automatically change their airflow depending on altitude and mission requirements. At low altitude, they maximize thrust. At high altitude, they become highly efficient. During combat, they instantly switch into maximum power mode. The transition happens almost instantly. No pilot adjustment required. Artificial intelligence constantly monitors engine performance thousands of times every second. If one engine experiences a problem, onboard systems automatically redistribute power and recommend the safest flight path. Even maintenance becomes smarter. Tiny sensors located throughout the aircraft continuously inspect the airframe for microscopic cracks, overheating components, hydraulic pressure changes, and structural stress. Instead of waiting for something to fail, Eagle One predicts failures before they happen. Maintenance crews receive automatic reports immediately after landing. This dramatically reduces repair time and increases mission readiness. Future air forces may spend less time repairing aircraft and more time flying them. Weapons are another area where Eagle One represents the future. Traditional fighter aircraft rely on missiles and bombs carried internally or externally. Eagle One expands those possibilities. Its internal weapons bay is imagined to support multiple mission configurations. One mission may require long-range air-to-air missiles. Another could carry precision-guided bombs. Another could deploy electronic attack pods. Future versions might even include directed energy weapons. High-energy lasers have already been researched for military applications around the world. While many challenges remain, laser technology continues advancing every year. One day, aircraft like Eagle One could potentially destroy incoming missiles using concentrated beams of light traveling at the speed of light itself. Imagine launching no missile at all. Instead, an invisible beam instantly disables the threat. No explosion. No smoke trail. Only complete precision. Although this technology remains under development, many defense experts believe directed energy systems will become increasingly important over the coming decades. Survivability also extends beyond combat. Future aircraft must operate in every environment imaginable. Heavy rain. Snow. Desert heat. Arctic cold. Ocean humidity. High-altitude turbulence. Eagle One's conceptual airframe is designed to withstand extreme conditions while maintaining exceptional performance. Special protective coatings reduce corrosion. Advanced composite materials resist fatigue. Stealth surfaces automatically maintain their structural integrity despite harsh weather. Every component is engineered for durability. Long-range operations become another defining strength. Modern aerial refueling already allows fighters to remain airborne for extended periods. Future autonomous tanker aircraft may make this process even safer. Artificial intelligence could guide Eagle One directly into perfect refueling position with almost no pilot workload. The aircraft remains focused on the mission while computers handle the precision flying. Perhaps one of the most fascinating aspects of Eagle One is how it changes the relationship between humans and machines. Instead of replacing the pilot, artificial intelligence enhances every decision. The pilot remains in command. The AI remains the trusted partner. Together they react faster than either could alone. Military historians often compare revolutionary aircraft to the first appearance of the jet engine or stealth technology. Eagle 1 represents another leap forward. Not because of one single invention, but because it combines dozens of emerging technologies into one unified system. Stealth, artificial intelligence, adaptive propulsion, sensor fusion, electronic warfare, drone coordination, predictive maintenance, directed energy concepts, network-centric warfare. Each technology already exists in some form today. The future lies in bringing them together. That is exactly what Eagle 1 symbolizes. It is more than an aircraft. It is a vision of tomorrow's battlefield. A battlefield where information travels faster than bullets. Where artificial intelligence processes millions of calculations every second. Where pilots command entire formations of autonomous aircraft. Where stealth extends beyond radar into every detectable spectrum. And where victory belongs not only to the fastest aircraft, but to the smartest one. Whether Eagle 1 itself ever becomes reality is impossible to know. But the technologies that inspired it are already shaping the future of aviation. Every year, engineers push the boundaries of what aircraft can achieve. Every year, new materials become lighter and stronger. Every year, artificial intelligence becomes more capable. Every year, the skies become more advanced than ever before. Perhaps one day, an aircraft remarkably similar to Eagle 1 will roll onto a runway somewhere in America. Its engines will ignite. Its sensors will come alive. Its artificial intelligence will begin analyzing the world around it. And history will witness another giant leap in aviation. Until then, Eagle 1 remains an extraordinary vision of what tomorrow's fighter aircraft could become. If you enjoyed exploring this futuristic concept, make sure to subscribe to the channel, leave a like, and share your thoughts in the comments. What feature impressed you the most? Its Eagle-inspired design, AI-powered cockpit, stealth technology, or autonomous drone control? Thanks for watching, and we'll see you in the next aviation adventure.